All right, arithmetic series. The sum of the terms of an arithmetic sequence is an arithmetic series. So if an arithmetic sequence has the first term a sub 1 and a common difference d, then the sum of s sub n of the first n terms is given by this formula, and we're going to build and create it. So let's say we take 1 through 20, and we want to add them together. All right, well, I'm not going to go 1 plus 2 plus 3 plus 4. That's crazy. What I'm going to do is I'm going to take the first term, add it to the last term. That's 21. Now, the second term and second to last term is also 21. And 3 and 18 is 21. If I group them like this, I will have, let's see, 20 numbers divided by 2 is 10 groups. So I'm adding 10 21s, which means that's 21 times 10 or 10 times 21. My sum's 210. So with that, let's build our formula. Where did these numbers come from? Well, the 10 came from 20 over 2, and the 21 came from 1 plus the 20. Now, let's put this in a sub 1 terms. All right, 1 is a sub 1, 20 is a sub 2, so we're going to put those numbers right there. And then the 20 is my n. Wait a minute. This 20 then, well, that would be a sub n. We're going to change all the 20s to an n. So a sub 1 is 1. A sub 20, that's our last term, so we're going to call that n. This 20 is your n. This 20 is your n. There's my formula. Now, because this formula has a sub n in it, we might need to have this formula hanging around in case we have to go find the last term. All right, so let's practice this. So here's an arithmetic sequence: -9, -5, -1, 3, and 7. Evaluate the partial sum, which means the sum of the first 12 terms. So I need a sub 1, n, and the d. Nope, not the d, excuse me, the last term. I'll use the d to find the last term. So 12 terms, I have the first term, need to find a sub 12. So that's this formula coming into play. So d, 7 minus 3 is 4. We'll put a 4 there. We'll put the 12 in for n. We'll put -9 in for a sub 1. We'll put a 12 over here. And now we can find the 12th term. So let's see, 12 minus 1 is 11 times 4 is going to be 44. 44 minus 9 will be 35. So we have our 12th term. Now we can go to our formula, s sub 12. All right, the sum of the first 12 terms is going to equal to 12. That's our n over 2. That will be a 6. Your first term, -9, plus your 12th term, 35. So we have 6 times, what would that be, 26? That's 156, and there's my answer. Now, B is kind of interesting. It says, evaluate the sum of the first 60 positive integers. Okay, so my first 3 were negatives. So if I want the next 60 positive numbers, I'm going to have to go out to 63. So starting with 3, which is technically a sub 1, 2, 3, 4. I hope I wrote this in right. A sub 63 will be -9, the first term, plus our difference 4. 63 minus 1. Okay, well, that's 62. 4 times 62 is 248, minus 9, 239. All right, so the sum of the first 60 terms that are positive, we'll treat the 3 like it's the first term and the 63rd term like the 60th term if we're just looking at positives. So 60 divided by 2. 3 is the first positive, 239 is the 60th positive term. So that's 242. 60 divided by 2 is 30. Multiply those together, we get 7,260. All right, using summation notation and using your arithmetic series formula by identifying, hey, look, this is linear. X to the first, I to the first, it's a linear function. Arithmetic sequence is linear. D is your slope. So you could use your formulas, or here we could take S sub n, n being 10. So we'll put a 10 in for n. Find your first term, plug the 1 in for I. So 4 times 1 is 4 plus 2. That will be a 12. Take the 10 and plug it in for the I. 4 times 10 is 40 plus 8 is 48. So let's see, that's a 60, that's a 5. 5 times 60 is 300. Over here might be a little more difficult because you're not starting at 1. So to revamp this one, your first term is a sub 3 plus a sub 9. Now the 9 is not going to be your n because we don't have the first term and the second term. So 9 minus 2 is 7, that's my n. And then my a sub 3, I got to put 3 in here, so 3 times 3 is 9. 4 minus 9 is negative 5. Then I got to put 9 in for k, so that's 4 minus 27, that's negative 23. So 7 goes in for n, so the sum of those 7 terms is 7 over 2 times negative 5 minus 23. Well, can't simplify what's outside, so this better be an even number. It's negative 28. So 2 goes into 28 14 times, becomes negative 14 times 7 is negative 98. Some application problems. It says a stack of telephone poles has 30 in the bottom row, 29 in the next row, and so on all the way up to one pole at the top. So it's like a triangle of poles. How many poles are in the stack? Well, we have n equals 30 for 30 rows. A sub 1 is 1 because we'll count that as the top pole. And an a sub 30 will be 30. So we can plug everything in. S sub 30 is 30 divided by 2, which is 15. 1 plus 30 is 31. 15 times 31, 465 poles. My last word problem here says the normal growth pattern for children aged 3 to 11 follows that of an arithmetic sequence. An increase of 6 centimeters per year is average. If a child measures 98.2 centimeters at age 3 and 109.8 at age 5, what would be the common difference of the arithmetic sequence describing this yearly height? All right, so we start with 98.2 plus 2 d's. 3 to get to 5, we're adding 2 d's, equals 109.8. Solve for d. Subtract over the 98.2, we get 11.6. Divide by 2, d is 5.8. So this child is close to the normal average. What would we expect his height to be at age 8? All right, so we need to find A1. What was the age of the first year? So a sub n equals a sub 1 plus your d, which we said is 5.8. And we're going to take 3 for your n, 98.2, put that in here for a sub 3. Solve this for a sub 1. So 58 or 5.8 times 2 is 11.6. Subtract it over. You get 86.6 for a sub 1. Now we'll write our function a sub 8, because we're looking for the 8th year, the 8th term, equals your first term, 88.6, plus your d, 50 or 5.8. I don't know why I want to call that 58. And then n minus 1, your n was 8. So let's see. I'm not going to attempt to do these decimals. I went right to my calculator. 86.6 plus 5.8 times 7 gave me 127.2 centimeters for their height. And that wraps up our arithmetic series.